let's get a calculator now and go into the details of this video. Very simple, guys. Okay, so the first thing you have to do, which I always recommend, is to clear a calculator. The essence of clearing a calculator is to remove or wipe out whatever previous value you might have stored in the calculator, so that you will be at a safe side. You will not end up having the wrong values as answers. Okay, so having known that, let's clear to clear, you simply press shift button 9, then follow the instruction. Once you initialize or press 3, press quotes, and then press quotes again. Now, what the client does is to put your calculator in default mode. Okay, so having known that, let's go ahead and solve this particular problem. Unlike when you are solving indefinite integration, in which you will have to simplify a question and then differentiate the option. In the case of definite integration, it's very straightforward. You don't need to store any number. You don't need to simplify the question and differentiate the option. All you have to do is to impute the value straightforward and solve for it, and your answer will display. But there is one thing you have to take note of, which is to put your calculator in radii, not in degree. As you can see, when your calculator is in default mode, it's always in degree. So you have to change it from this degree to a reduce mode. To do that, you simply press shift, this menu button, then go for angle unit option 2, then radian option 2. So that's it, guys. We are good to go. So this question 1, let's solve this question 1. After it, you solve question 2. Ensure you watch this video to the very end so that you get the full information on how to do or solve this kind of problem with the calculator. Okay, so to solve question 1, all you have to do is to press this button. If you look at this button closely, you see the definite integral sign, and you just press this one as you come out. So you move up and put the upper limit, which is 1. There, come down, lower limit is 0. Then you move this key to this center and impute what we have cube root of x raised to power 3 minus x raised to power 4. Okay, so to bring out the cube root, very simple, guys. All you have to do is the cube root is here. This button, sorry, this is the button you press. So you press shift first, press shift, then press this button to come out. As you can see, cube root of what? X raised to power alpha x. To bring out x, you press alpha and x raised to power. All you have there is 3. You can make use of this function, that button, then come down, minus alpha x raised to power 4. Yeah, so the ds is not part of the question. What the ds stands for here is function. These of you interpreting this question as the definite integral of these values, what you simply say is that the definite integral function of the values you have here. It's as simple as that, guys. So having done this, let's press equal to and see what we're going to have. Very simple, guys. Press equal to. Okay, so the calculator is solving the problem. Very simple, guys. So you wait for a few seconds to see your answer. Very simple, guys. Okay, the calculator is solving a problem. Well, this question is heavy. This one, the calculator is taking this level of seconds to solve it. Okay, guys, let's do the patient. The answer will display. This shows that the question is heavy. Okay, guys, so finally we have 0.321. So what we're going to do now is to simplify the options. You see the one that give us 0.321. Very simple, guys. So option A is already 0.5, which will not work. So we'll begin with option B. 1 over 2 something as 0.5. That's half. Let's check option B and check if it will give us 0.321. Okay, guys. So check option B. To convert this to decimal, all you simply have to do to press equal to here, then press SD. Though we have 0.321, let's check option C. Okay, so you go with the necessary adjustment, put 9 over, we have 28 over 28. Very simple, guys. Okay, let's convert it 0.32 exactly. So guys, option C is our answer, but let's check option D and see what it's going to give us. But we have already known our answer. Our answer is what? Option C. It's as simple as that, guys. Okay, so we are good to go. 3.2. No, so guys, our answer is what? Option C. Now let's solve this question 2 that looks somehow very simple, guys. Let's solve it. You're going to see the answer now. So we press this button and to come out, to put the upper limit, we have the upper limit to be 1 and lower limit to be 0 as well. So you move this key, this cursor to here, and in pure you have here, we have x, so press alpha x raised to power 5. That's what we have there, guys. Okay, you come down, plus we have 6x alpha x raised to power what? 4. Use this power function raised to power 4. Okay, you come down, we have, oh yeah, we have plus 5x alpha x, you press alpha x raised to power 3. Okay, you come down, we have plus 4x alpha x raised to power 2. Okay, plus 3x. Okay, guys, alpha x. All right, then plus 1. That's what we have there, guys. Okay, guys. Okay, we are correct. Ensure everything is intact. As you can see, that's what we have there. The question started with brackets, and that is exactly what we have there. Very important, guys. Okay, so we close the bracket here and put this exponential. To bring out the exponential, press shift, this button, no, sorry, you press shift, this lane button to come out. Then the power of the exponential is x alpha x minus 1, right? So nothing else. So the ds is not part of the question. What it stands for there is function. So having done imputing the right values, just press equal and see what we're going to have as the answer. Very simple, guys. 5. So guys, the answer is what? 5. As you guys saw, option A. Very simple. Let's check option B as well. We're going to have 5 exponential. Let's make use of exponential that does not have power. You press alpha and this, it will come out. No. Okay, let's take this one that has power. Let's put the power 2. No, let's change it and put 4. Just playing with this. Okay, guys, so answer is not 5. It's as simple as that, guys. Let's go to the Casio calculator now and go into the details of what I have here. Alright, so this is the Casio calculator, the fx-991 ES. Okay, so I have 3 questions here. So ensure you stay with me till the very end of this video. Don't miss any part. Ensure you watch this video to the very end. Very, very important, guys. Okay, so now the first thing you have to do or know is that you have to clear your calculator. Very, very important. Okay, so having known that, let's clear. To clear, you simply press shift button 9, put instruction 1 to initialize all. You press 3, then press equal to again. So right now the calculator has been cleared. Now what clearing does is to put your calculator in default mode. Very important is to put it in default mode. Okay, so having done the clearing, the next thing we are going to do, remember, we want to solve question 1. After question 1, we'll go back to question 2. Now solving this question 1, you have to take note of some important points. The first one is that for solving indefinite integration with the Casio calculator, one is that you have to store a value, which is 2. I recommend always. Now you can work with any other number, but I recommend 2 because I have worked for a very long time with 2 and I have not found any error with. So you store 2, So right now we're going to store 2 in this calculator. So to store 2, you press the number first, 2. Now to store 2 here now, unlike in the white Casio calculator fx-991 ES plus the white one, if you have to store this number, you first of all press shift, then press store and this alphabet X. But in this black one, you don't press the shift. The only thing you have to press is just, or the two things you have to press rather is this store and this alphabet X. Very, very simple, guys. So you press this store and X. Once you do, indicate here that 2 has been stored as X in this word calculator. Remember, you don't press shift. If you press shift and store, it will not work. It's in the first, in the white one that you press shift, store and X. But this one, don't press shift. The only press was store and X, and the value will be stored. But having stored this value here, the next thing you have to note is to put your calculator in reduce mode, guys. For solving integration, to be at the safe side, ensure that your calculator is always in reduce mode. Don't solve it in degree. Okay, so having known that, to put this calculator in reduce, all you have to do is press shift menu, then category 2 angle unit, press 2, then radian option 2. So it's now in reduce. If you can see, it has changed the degree here to reduce. Okay, guys, having done these 2 things, now we are good to go. Now let's go ahead and solve this problem. Now the idea behind solving indefinite integration is to evaluate or simplify the question and then differentiate the option. Now we're going to simplify this question have here or evaluate it. To simplify this question, all you have to do is impute this question exactly as it is appearing here. We have to find the indefinite integral of this question. So to do that, let's impute what we have. They have 2x alpha x, okay, square plus x alpha x. Very simple, guys. Raised to power 3, then press equal to 16. Okay, guys, we have what? 16. So what we're going to do next now is that we are going to differentiate the options to check the one that gives us 16. And then what happens to give us 16 will be our answer. Very, very simple, guys. So remember, I have 16. So let's differentiate. To differentiate, you press shift button. This button has integral sign on it to come out. So let's differentiate option A. The starting is in fraction. Okay, we have 2x alpha x cube raised to power 3. Okay, come down over 3. Okay, that's what we have there, plus fraction. Okay, we have alpha x raised to power 4. Very simple, guys. So interesting. Over 4. Okay, plus c. Now the plus c is not part of what we're going to impute here. The plus c there is just a constant, so you don't have to put it here. So having impute these respective values, let's go and put the 2 is stored. I think we stored another number. When you come here, put the number, but since we stored 2, what we are going to put here is 2 is stored, right? So press equal to and see what it gives you. 16. Okay, guys, so option A was our answer. Is it was 16? Okay, let's check option B and see if we have something similar or something close. But our answer is option A. And let us do some necessary adjustments. Okay, the difference there is just the power. Remove this 4 and put 2. Now is for option B. Okay, the difference here is there is no power in the option B here. Okay, so this for option B, correct? Okay, let's put 3 downward. Put 3 downward. Okay, 2. Sorry, not 3. Put 2 downward. That's it, right? Yeah. 2. No, it's not correct. Okay, so guys, okay, let's check option D and see what we're going to have here. Okay, option D. Quickly, let's check option D. Put 4 here. All right. What do you have here? We have 3. Put 3 there. Go up. Okay, we have x raised to power 3. And here we have 4. Move this and put what? 4. Okay, that's it, guys. Let's put equal to 24. No, so guys, the answer is what? Option A, 16. So that's it. Let's solve another example. Example 2. Guys, hope you understand what I'm trying to explain here. Very simple, guys. Now ensure you watch this video to the very end. Very important. So that you know how to solve this one that involves hyperbolic function. Very important, guys. This one is very critical. So ensure you watch till I solve this question that involves hyperbolic function. Now you not miss out on it. Alright, guys. So I've been known that. Let's quickly solve example 2. So we are asked to evaluate the integral function of s raised to the power 4 ln x. Okay, guys. Very simple. Now you don't have to clear a calculator because we are still working with the 2 we stored. It's only when we are going to store a new number that we have to declare. But since we're not going to store a new number, we're going to still work with the 2 we already stored. No declaring. So we still work with the 2 we stored. So what we do here now is to simplify this indefinite integral. So to simplify, simply we have x alpha x. Very simple, guys. Alpha x raised to the power 4. Okay, guys. Very simple. Ln x, look at ln x alpha x. Close the brackets. Okay, are we missing anything? Ln x raised to the power 4 ln x. Okay, guys, that's it. Let's press equal. That's what we're going to have. 11.09. Okay, guys, so as usual, let's differentiate the option and see the one that give us 11.09. As simple as that. So you go to here, shift this divided by this integral button. You see the divided by the s on top of it to come out. Then let's use option A. We have x alpha x raised to power 5, alpha x power 5 over 5. Very simple, guys. Then adjust. We have ln x alpha x alpha x. How I press? Okay. Close the brackets. What do we have there? Minus. We have minus a fraction. So we have alpha x. Very simple, guys. Raised to power 4. Okay, over 5. Then we also have ln x alpha x. Okay, close the brackets. That's all, guys. So you don't put the plus c is a constant. Now, guys, ensure that one more point I have to take note of is balancing of brackets. Ensure that brackets are always balanced so that you not end up having syntax error when you press equal. So let's check if the brackets are balanced. So let's check the bracket at the left hand side. Okay, we have one. Oh, let me start from. Okay, we have 1, 2 at 3. Okay, we have 1, 2, 3 at the left. Let's check for the right. We have 1. Okay. 2, 2, and 3. So it's balanced. So go over here and put the 2 we stored. Very simple, guys. 8.25. No, we got 11.09. So let's check option B. Let's check what was option B saying. Let's check it. None. Okay. Let's check option C. Option C. Let's simply adjust and put the necessary information there. There's no starting from the beginning so that we will not waste time. Okay. Minus the difference option C is the power here. The power here is 5. Power here is 5. Remove this and put 5. Very simple, guys. And down at the denominator we have 25, not 5. Okay, so let's put equals. That's the difference. Okay, there's no lane. There's no lane to it. So I mean, we have to clean this lane. Yeah, so that's what we have there. Right, that's what we have. We have x to the power 5 ln x minus s to the power 5 by 25. So let's see the bracket are balanced. Then yeah, we have 2 here, 1, 2. We have 1, 2. So it's balanced. So let's put equals. That's what we are going to have now, guys. Very simple. 11.0 confirmed. So guys, this is our answer. Option was C. So this is the value we got when we simplify the question. Okay, let's check option D and see if we have something similar. Option D. What's the difference? Let's just check. Okay. Oh, the difference is just the plus. Here we have minus. We have minus here. Just let's put plus, and we'll be good to go. Right. So let's put equal. That's what we're going to have now. No. So our answer is option C. It's as simple as that, guys. Okay. So having watched the very end, now let's solve the very last one we have here, which is question 3 that has hyperbolic function. Hope you are flowing, guys. So we have to evaluate this indefinite integral function. So let's, as usual, we're going to simplify the question with the stored value. No need declaring the calculator because the 2 is stored is still effective. So to do that, we have exponential. To bring out the exponential, press shift this button, lane the exponential will come out. Then we have x, alpha x, then come down, press this button to come down. We have cos h, this is a hyperbolic function. So we press cos. Now to bring out, okay, no, let's just cancel, let's delete this. To bring out the hyperbolic function, what you simply have to do is press option. Here you see option, you press the option, then you see hyperbolic function, you see question, category 1 rather. Then what kind of hyperbolic function do we have? We have cos h, which is option 2, guys. Press 2. So that's it. It's as simple as that, guys. Then press alpha x to bring out, put the x, close the bracket. Then the here is not part of what we're going to put. What the here stands for here is function. So it's not part of what we're going to impute here. So having done this, let's put equal and see what we're going to have before we differentiate the option to get our answer. So we put equal to 27.179. Okay, guys, so let's differentiate the and get our answer. Very simple, guys. So let's begin with option A. Alright, so we have shift this integral sign button to come out. So option A, there we have what? Exponential. Shift this lane button to come out. This power x, alpha x. Very simple, guys. Okay, come down. Now you have hyperbolic function there. It goes back to option 1, which is hyperbolic function. You press 1. Okay, so we have sin h, which is still 1. Press 1. Okay, that's what we have there. You put your x, alpha x, close the brackets, check the bracket balance. We have 1, 2 here, also 1, 2 here, so it's balanced. So you go over here and put the 2 is stored, right? So you put t here, press equal to. No, this is not what we got. So let's check option B. What is option B saying? None. Okay, guys, let's check option C. Option C, we got 27 point something. Look, option C. Let's just go back and delete all we have here since it's starting with fraction. So we begin with a fraction. Very simple, guys. So we have 1 over 4. Okay, 1 over 4 exponential, shift lane. Then we have the 2x alpha x. Okay, then come down. That will have the right side. We have plus. Then another fraction. We have x alpha x over 2. Very simple, guys. The c, the plus c is not part of the question. So since we are 2, we only have it here. No need imputing it. So let's look at what we're going to have now, guys. Very simple. Let's check again. Is what we have there. Yes, correct. So let's check press record and so we get the right answer now. Confirm. So guys, option C is what our answer. This was the value we got when we simplified this to 27.79. So option C is what our answer. Let's check option D and see if we get something similar. Very simple, guys. So quickly, let me just adjust this. Okay. Let me just delete this and no fraction there. We have x alpha x. Go to this side. Put 2 here. Very simple, guys. That's what we have there, right? So press equal to. No, so our answer is what? Option C. So guys, this is basically I can solve problems involving indefinite integration with this particular Casio calculator in seconds for multiple choice questions. Okay guys, let's get the Casio calculator now and move straight to the details of this video. Okay, so this is the Casio calculator, the black one. This is the fx-991 ES calculator, classwiz. Okay guys, so I have 3 questions here, as you can see. So ensure you stay with me till the very end of this video, because the question 3 that involves indefinite integration is quite different from the first 2 questions, because this question 3, the method we apply to solve it will be different from the method we apply to solve question 1 and question 2. So guys, ensure you stay with me till the very end of this video so that you get the full information. Okay, having known that, now the first thing you have to do with the calculator is to clear it. Now the essence of doing this is to put your calculator in default mode so that it will remove or wipe out whatever previous value or mode you might have placed your calculator on. So to clear your calculator. For those of you that don't know how to do it, to clear it, all you simply have to do is to press shift button 9, follow the instruction. Now once you initialize or press 3. Now you have to press equal to, yes, then you have to press AC key. It's either I press AC key or press equal to again, but let's press equal to again. So the calculator is now cleared. Now that you are cleared, it's not in default mode. If you check closely, it's in degree. Anytime you clear a calculator, anytime it's in default mode, usually in degree. Now for integration, your calculator has to be in radii mode, not in degree. Very, very important, guys. Take note of that. So don't solve it in degree. Put it in radius. To put it in radius, simply press shift this menu button. Now for the instruction, angle unit, go for option 2. Now option 2 is radian. No, option 1 is degree. It's already in degree. You want to put it in radian, press 2. So guys, now in what? Radian. Very important. Okay, having put your calculator in radian, let's go ahead and solve the questions we have here. So question 1 is definite integration. Is usually straightforward, guys. So we, as you can see, find the value of the integral above. Definite integral of log in bracket sec theta minus tan theta bracket close d theta. Okay guys, so very, very straightforward. All you have to do now is to press this button that has definite integral sign on it, and to come and input the upper and lower limit respectively. So you move this cursor up and put the upper limit is in fraction. We have pi. To bring up pi, guys, press shift this button, click at pi here, and to come out over 4. Then come down, put the lower limit, you have it to be minus. Then in fraction, pi, shift this button over 4. Then adjust the cursor to this middle box and put what you have log. Okay guys, don't use this log. Look at the log you use here. To bring out the log, press shift this button and to come out log. Now in bracket you have sec theta. Now guys, there's no sec in this calculator. Now if you observe or check very well below here, you see I have written notes. Cos theta is the same thing as 1 over tan theta. Sec theta is the same thing as 1 over cos theta. And cos sec theta is the same thing as 1 over sin theta. So guys, what we are going to do simply is to replace sec theta with 1 over cos theta, since there is no sec here. Very, very simple, guys. Because in trigonometry, another term or language for sec theta is 1 over cos theta. The same thing is applicable to cot and cosec respectively. Okay guys, so instead of putting sec, we put 1 over cos, that is in fraction. So we have 1 over cos. This is our cos. So we replace the theta with x. Very, very simple, guys. Because here I say we are theta is something as x. So we close the bracket. We are good to go. So what do we have there? We have minus tan theta, that's an x. Very, very simple, guys. Close the bracket. Okay, so check the bracket are balanced. Very important, guys. Ensure the bracket are always balanced. You can see at the right hand side how many brackets we have. 1 and 1, 2. So at the left we have 2, 1 and 2. We have at the right we have only 1. So add 1 more at the right to balance it. So guys, it's not balanced. Let's press equal to and see the answer. We have 0. So guys, see the answer is 0. Very, very simple. Let me show you the essence of balance the bracket. Now let me show you guys. Just watch. If I remove one bracket here now, then I have syntax error. See, the brackets are not balanced. Let's press equal to see syntax error. So there is need of balancing what the bracket, guys. Don't forget that. Let's put it back so that we get our answer 0. So guys, it's as simple as that. So that's for question 1. Now let's solve a similar question. That's question 2. Our option is option B, 0. Now let's solve question 2. So it says evaluate the definite integral function of these values. So you press this symbol again. So you put the upper limit. Upper limit is in fraction. That's pi over that shifts this pi commas pi over 4. Okay guys, over the lower limit is 0. So move the cursor to this middle box. It's in fraction. We have sine 2 theta. Okay, sorry. Okay, we have sine, yes, 2 theta alpha x, then over, we have cos raised to power 4 theta. Guys, now pay attention in what I'm going to do here, and it's very important because if you're not careful, this might confuse you or make you solve something else. So guys, what this means is you should duplicate this cos theta up to 4 times. That you should do cos theta times cos theta times cos theta times cos theta up to 4 times. Now, if you don't want to, waste time, do it like that. The simplest way to do it, to represent it on this calculator, is to press cos, then we have theta, that replace with x, alpha x, close the brackets, then put the power, use the power function and put 4. So this is the easiest way to do it. This is the same thing with what we have here. Then we have plus, we have sine, the same thing for the sine, alpha x, close the brackets, then raise to power 4. So guys, that's it. No brackets to that question. Okay, we are good to go, guys. Let's press equal to and see what we're going to have as an answer now. 0.78. So option A says 0. Okay, guys, so let's check, simplify option B and option C, and see they want to give us 0.78. Let's give us option B. Right, with pi, shift this pi commas over 8. Press equal to. Now to convert this to decimal, press SD. 0.390. We got 0.78. So let's quickly check option C. Just adjust it here, guys, and remove this 8 and put 4. Very simple, guys. Press equal to. Now let's change it to decimal. Exactly. So guys, this is our answer. Option D says pi. Yeah, pi. So guys, our answer is what? Option C. Very simple. So lastly, let's solve question 3. Hope you are learning something interesting, guys. So question 3 is indefinite. Now for indefinite integration, the approach is different from solving definite integration like question 1 and 2 we just solved. So for this question, how we do it, since it's indefinite, you need to store a number. Now you can choose any number you want, but I usually recommend 2 for people I teach. So instead of using 2, because I have worked with it for a long time and I have not found any error with it. There were some cases I used other numbers and it didn't give me the precise answer. But since I've been working with it, I've always gotten the right answer of value. So that's why I recommend 2 for people I teach, guys. So to start 2 on this calculator, press 2 first, then press shift. No, don't press shift, guys, sorry. Pressing shift is for the white one. For this one, don't press shift. Once you press the number first, go ahead and press this store. And the alphabet you want to store it as X. Press this button and indicate here that 2 has been stored as well X. Very important, guys. Don't go and press shift. Now let me show you. If you just press 2 and go and press shift and this, you will see this something else. It's very confusing, guys. So don't press shift, just press the number once, then this and this, and indicate here that 2 has been stored in the calculator. So guys, having stored this number now, the idea behind this is to simplify the question or evaluate the question and then differentiate the option for indefinite integration, guys. So having known that, let's go ahead and simplify the question. After simplify, whatever you have, we use it to differentiate the options to see the one that we align with the value we will get from simplification. Okay, guys, so let's simplify. So we have exponential, press shift, lane, exponential commas, raised to power x alpha x. Okay, guys, so we have sec x. There is no sec, we put 1 over cos. Okay, guys, let me do something now. Sorry, let's put the fraction first before the exponential so that we not get confused. So we understood what I just did. Okay, guys, so now we have 1 over cos x sec x, the same thing 1 over cos x alpha x, close the brackets. Okay, guys, that's what we have there. So go here, put in brackets. Remember, this is a question we are simplifying. Simplify this question. Then we have 1 plus tan x, that is tan here, So this is the tan x alpha x close the bracket. So the dA is not part of the equation, guys, so no need imputing it here. So this is the only what we have to simplify. Exponential raised to power x sec s in bracket 1 plus tan x. So that's it, guys. Let's press support and see what is going to give us 21.04. So now that we have 21.04, we're going to differentiate the options to see the one that gives us 21.04. So the one that gives us 21.04 will definitely be our answer, guys. So let's go ahead and differentiate option A to bring out d over dx. Press shift this definite integral sign button and it will come out. So yes, differentiate option A. So let's begin with the fraction 1 over cos. Do not have that issue again. So we have put the exponential and shift lane and to come out alpha x. Okay, so guys, we have 1 over cos, since whatever is sec s alpha x to the bracket, guys. Okay, so go ahead and put the 2 is stored. Then we store the different number. When you get here, you put that different number, but since it's 2 is stored, what we put here the 2 is stored, guys. Very simple. Put the 2 stored here. One more thing you have to take note of: ensure your brackets are balanced. I think I've said it before when I was solving this question 1. So guys, very important, ensure that your brackets are always balanced. So having known that, let's press record and see if we have 21.04. Confirm. So guys, our answer is option A. It's as simple as that. But let's check option B and see if we have something similar. So what's the difference? Just go back and put plus for option B. No plus. Just put tan x alpha x in the brackets. So check the bracket balance. We have 3, 1, 2, 3. Let's check the right and the left. We have 3, 1, 2, 3. So the bracket balance is equal to. So we have no. Then what is option C? Option C is okay, exponential. So the only thing you have to do is to remove this 1 over cos. Now we have there. Balance the bracket, guys. Very, very important. Balance the bracket. Is that correct? Yeah. So 2 here, 2 here. So it's correct, guys. Let's press equal to. Don't put the plus c, guys. Don't put the plus c. The plus c is just a constant. So our answer is what? Option A. Is the we don't give us 21.04. So guys, this is it. Don't forget, because as some questions you will see you see cot in it, and there are some you see cosec. So when you see cot, you place it 1 over tan, and when you see cosec, you place it 1 over sine. And just as we saw sec here, we place it 1 over cos. It's as simple as that, guys. So with this, we have come to the end of the class. These are the tricks, the hack I used to solve problem involving trigonometric integral with the Casio fx-991 ES calculator, the Casio fx-570 ES calculator. So learn something interesting from this video. If you are new to the channel, ensure you hit the subscribe button for more videos like this. Also like, share and comment on this video. Tell me how you feel from what I've learned from this class. If you seem to have any specific questions to ask, feel free to leave your question in the comment section below, and I'll be sure to give you a response. Thanks for watching. I will see you in my subsequent video.